Alright, so continuing on with where I left off, the range rule of thumb says that the minimum acceptable value is found by taking the mean, subtract that to 2 times the standard deviation, and the maximum acceptable value is found by taking the value of the mean plus 2 times the standard deviation. So in general, if you take a graphic look at the max and the min usual value, perhaps a number line might demonstrate this concept. On a number line, we always put the average in the middle, and then this value over here, which is 2 standard deviation away, it's considered the maximum acceptable value. And then this value over here, which is 2 standard deviation to the left, it's considered to be the lowest acceptable value. So any number that's within this boundary right here, it's what we consider to be usual value, and anything that's outside that boundary is considered to be unusual. Okay? Alright, so let's take a look at an example on how to find the mean, the standard deviation, and perhaps the maximum usual and unusual, which is a concept that we've talked about before. Say that 200 free throws will be attempted, and the probability of success per free throw is 40%. What is the average number of free throws that will be made out of 200 and the standard deviation? So the first thing we do is we find the mean, which is equal to n times p. Okay, in this case, n is 200 because the number of trials is 200. The probability of success is 0.4. So we go ahead and we multiply these together, and we get 200 times 0.4, and that gives us 80. So we know that an average amount of free throws that will be made is about 80 free throws if you shot 200 free throws. Now, what is the standard deviation? The standard deviation, represented by the letter S, found by taking the square root of n, okay, times, see this n over here, n times p times q. Okay, so p is 0.4, and remember q is kind of like the opposite of 0.4, which is 0.6. And what I mean by that is it has to add up to 1. So if a player has a 40% chance of making it, then he has a 60% chance of not making it, and that's q. Multiply those together, take the square root, and that's the standard deviation. So here we go, the square root. Second, and then you go to this button that looks like an x square that will prompt that square root notation, and then you type in 200 times 0.4 times 0.6, and that's all you have to do, and it gives us about 6.93. okay, so you get about 6.93, which is the value of the standard deviation. Now, so we found that in question 1, and question 2 says what's the acceptable range using the rule of thumb. So the min acceptable range would be like taking the average minus twice the standard deviation. That's 80 minus 2 times 6.93. And let's see what that is. So 80 times minus 2 times 6.93, and we're looking at 66.14 shots that will be made, and the maximum acceptable value is found by taking the average plus 2s. 80 plus 2 times 6.93, because that's what S is. Let's see, we take 80 plus 2 times 6.93. That brings us to 93.86. So we say that the acceptable number of free throws that will be made out of 200 is between 66 and 93. Or to be more specific, 66.14 and 93.86 free throws. If you're going to shot 200 free throws, you're expected to make between these two numbers, this amount, given that you shot only 40%. Okay? Alright. Now, a new concept that I want to introduce to you today is called a probability distribution function or table. Alright? What this is a table or a function that summarizes all the possible probabilities. So let's create one together so that you can understand what a probability distribution function or table is. Okay? So let's say that a basketball player is a 75% free throw shooter. In a game, he takes 10 shots. Find the probability distribution function. So in other words, we want to create a table that summarizes his probability for what's the chance that he will make 0 shots, what's the chance that he will make 1 of those 10 shots, what's the chances that he'll make 2 of those 10 shots, and so on and so forth. Okay, so this is a table that summarizes his probability of making this many shots. First, to be more specific, we need to know what X stands for. So X stands for the number of shots that the player will make out of 10 trials. Okay? And P of X stands for the probability that the player will make X amount of shots. Okay? So in order for us to find these, we just have to find the binomial probability for X equals to 1, X equals to 2, X equals to 3, and so on and so forth. Alright, and so the way how we're going to do this is we have 2 ways to find the probability of a binomial, but the easiest way is to use a calculator. So remember, second, and then you go to second var, okay, and then you go to, go down until you find your binomial. Remember binomial PDF, and you input the number of trial, which is 10. Your probability of success is 75%. He has a 75% chance of making it. Now, if you leave this input empty, then the calculator assumes that you want the probability for all the X values if you leave it blank. If you input a specific number, then it only outputs that specific number, the probability for that specific success. Okay, so I'm going to leave it blank and I'm going to paste like that, and it's going to give you this weird looking list. But the first number tells you the probability of making 0 shot, and then this is the first number, this is the second number. The second number is the probability of making 1 shot, and so on and so forth. So it lists everything for you. This basically means that there are 6 zeros before you get to the 9. So what this means, I'm just going to write down one of these for you. So what this means, 9.536743164 e to the -7. -7 means that you need to move this decimal to the left 7 times. And if you move that decimal to the left 7 times, you're gonna get like 0.1, 2, 3, 4, 5, 6, 7. Okay, and then you fill in these numbers and so on and so forth. This is the probability of making 0 shot out of 10 tries. Clearly, if we turn this into a percent, but usually we'll leave it as a decimal though. So if you look carefully, this is basically, we tend to just keep the first 4 digits, so it's 0%. So what does this mean? The probability that you are gonna make 0 shot out of 10 tries is impossible. In other words, you're gonna have to make at least 1. That's what we're saying. Okay, what's the probability that you're gonna make 1 shot out of 10 tries? So we look at the next number, and I think if you it doesn't let me scroll to the right, but some calculator that allows me to scroll to the right, but this calculator for some reason is kind of stubborn. So I'm gonna see if I can try something different to see if I can get a better result here. Let me delete that real quick. Go down here, go to option B. Okay, that's weird. Okay, one last try. Go down here, go to option B. Okay, I'm gonna try Binomial CDF, and then to see if I get better results. Leave that 0, paste. Okay, this still doesn't let me slide over. It's weird. Okay, usually what it does, it lets me slide over and I get to see everything, but it doesn't. So I guess I'm gonna have to do everything manually. But anyways, if you did this correctly, this is still gonna be 0, like this. And then I'll just try to do 2 here. Second var. But anyways, so the option you gotta select is this. It's either binomial PDF or binomial CDF, and then it should allows you to view the extensive version of this, but for some reason it's not. So I'm just gonna do it manually for each one of these. Unfortunately, it will take some time. Okay, it's being really stubborn. Okay, so let's start with the new line. Second var. Go down to this option, and then 10 trials 0.75, x value up to. This is easier if you like it like that, and it's again very small, 0.1, 2, 3, 4. That's what it's saying. Second var, option A, 3, 0.003. See how it shows up now? Second var, 4.0162. Second var. You have to do that until you get to 10. That's how you create a probability distribution table. Go to 5, and then that becomes 0.0584. We're going to round that up. Second var, option A, 6.1459, but that becomes a 6. Okay, so 0.146, and then second var. I guess this is a good practice to go into this option by doing it this many times, so that you know the exact key to use when you need to get here. So that, and then second var again, and then we go to this option 8. We're almost done here. This is how you create a probability distribution table. 1, 6, second var, and then you go to, and again, if you're doing this, then you can kind of slow down a little bit, pause the video. You don't have to go at the same speed that I'm going at. 7, 7, and then here's the last one. 0.0563. Okay, so guess what? We just found a probability for the number of successive out of 10 tries. So let's say, again, the player takes 10 shots. What's the probability that he'll make exactly 5 shots out of 10? 5%. If he takes 10 shots, what's the probability that he's going to make exactly 7 shots? Well, about 25%. So it's a table that displays the probability for all the successes out of 10. Okay, that's called a probability distribution function or table. Now, one big characteristic of a probability distribution function is that it has to add up to 1. So if I add up all these probability, it has to add up to 1 in order for it to be considered a probability distribution function. Now, if you really add these numbers up, it's going to add up to a number that's pretty close to 1. And the reason why it's not exactly 1 in our table is because we round these numbers. But make sure you keep that in mind, okay? If for some reason the probability for all the trials, for all the possible successes doesn't add up to 1, then it's not a probability distribution function. Okay, create a probability histogram for the probability distribution function in example 2. So what's the next part, and I'll show you how to create this.